Okay, so we're looking at mixed exercise 11 from the first year core textbook. So this is on vectors, and we're on question 13. So we're given two forces, and we're given the full information about force 1, and then we've got obviously two unknowns in force 2, and then we're not told what their resultant is, but we're told the direction its resultant is going in. So let's have a think about that. So in fact, for part A, I don't really even need to worry about those two forces, F1 and F2. So the resultant force is parallel to the vector 3i minus j. Okay, so that's the actual vector 3i minus j. So that's not r, well, that's not necessarily r, could be. But all I know for sure about r is it's parallel to that vector. So I'll try and draw this neatly. So it might be about 3 times as long. Yeah, that would be parallel to vector 3i minus j. It might be really short, so it might be only half as long. Okay, but anything that's parallel to vector 3i minus j is going to make the same angle with the I vector. So that's irrelevant to the length of it. So angle between r and vector I is basically going to be the angle between the vector 3i minus j and the I vector. Okay, so running out of colours, orange we haven't used. So you said that's the direction of the I vector. So angle theta is the one they're asking me for. So let's just sketch out the triangle, because that one's got a little bit of a mess. But basically, so I've got a right angle triangle because I and j are perpendicular to each other. That side's got a magnitude of 3. That's got a magnitude of 1. In terms of getting the angle theta, I don't care that it's a -1. It's a length of 1. So I'm using SOHCAHTOA, and tan theta is opposite over adjacent. So if I arctan 1/3, I get theta is 18.4 degrees, and then that's 18.4 degrees below the I vector. Yeah, that's purely from that diagram there. I can see that's below the I vector. Okay, all right, so then it's a show that question. So that's quite handy, because that means I'll know when I've got it correct. But for any show that question, you must be sure you're not kind of skipping stages. You're getting everything clearly written down on the page. Okay, well, so what do I know? Well, I know that the resultant, so they're telling me that the resultant of force 1 and force 2 is r. I'm going to switch to column vectors. You really don't have to. It's purely how you prefer to lay it out. So I'm going to switch. So rather than 4i minus 5j, I'm going to write it as 5 minus 4. It's quite good practice, because you need to be able to switch between the two or understand both. But you're perfectly fine to leave it in I and j. F2 is pi, so that's p in the x direction, plus qj, so that's q in the y direction. And now this is where I've got to be careful, and this comes up a lot. A similar thing came up in a second year exam question quite recently, and it did throw a lot of people. So I don't know that equals 3i minus 1j. Okay, that's not what it says. A slightly easier question, that might have been the case, but it doesn't say that that's what r equals. It says it's parallel to it. So I'm going to introduce another letter. We often use the Greek letter mu here. Let's just use an m, because it'll be easier to draw if you haven't used mu before. Okay, so I know, so we think back to this diagram here, I know that my vector is a multiple of 3 minus j. It might be a half of 3i minus j. It might be 5 times 3i minus j. It might be 1 times 3i minus j. So it might just equal 3i minus j. But that's what it means when it says it's parallel. It means it's a multiple of it. Okay, so they want me to prove something, or they want me to end up with just something with p and q in, not this new letter m that I've introduced. But if I think about what I've got there, I've basically got two equations. So I can look at the I components, or the x direction, and say that 4 plus p is 3m. Then I can also look at the j components, or the y direction, and say that minus 5 plus q is minus 1m. Okay, and then there's various ways I could simplify that, but they basically want me to eliminate m, because I introduced m or whatever letter I'd chosen to use. So I think the best way to do that, and there's plenty of variations, but I think what I'm going to do is multiply that second one by 3. So that would give me minus 15 plus 3q is minus 3m. I'll write the other one out again above it. And then add those two together. So 4 plus minus 15 is minus 11, and then I've got plus p plus 3q, and then 3m plus minus 3m is 0. There's lots of slight variations in how you might have laid that out. You could have multiplied this one through by minus 1 to make that m and then substituted it in. Might even have been a slightly nicer way to do it. Lots of variations though, but basically I think I'm okay. Obviously they've then just added the 11 over to the right hand side. So let's do that. And then this was a show that question, so it was a proof. So I'm just going to write that I have done it. Okay. And then if and then if you got a bit lost on B, that doesn't stop you doing C. So it's always worth carrying on with the question. So if P is 2, okay, so if P is 2, well, they gave us this. Or even more, if you'd done B and you didn't end up with this, obviously use what they gave you in the question. So if P is 2, 2 plus 3q is 11, so 3q is 9, so q is 3. Yeah, that's just substituting P is 2 into that. Okay, so q is 3. So I'll say what I might as well just do is go back to those two original, go back to this thing here. So R1, and again, I'm going to work in column vectors just because I prefer that. So R1 was 4 minus 5. We have just established that P is 2 and Q is 3. So as a column vector, that will be 2, 3. So R is 6 minus 2. I always do daft things like that. Yep, so that's just 4 plus 2 for my x direction or my I component. Minus 5 plus 3 is minus 2 for my j vector or my y direction. And then magnitude of R. So that comes up a lot, particularly mechanics, if you've started mechanics. So the magnitude of R is just going to be using Pythagoras. I'll put the minus 2, but obviously that's just going to be the same as 2 squared. Yep, so just to clarify what we're doing here. So this vector R is going 6 right and 2 down. So that is what vector R would look like. And we want the magnitude of it. So obviously R is the hypotenuse of a right angle triangle. So that's why I'm just basically using Pythagoras here. So magnitude of R is root 40. It does not mention, can't quite see that, does not mention exact form. So I'd be fine to or simplifying it to third or anything like that. So that should be acceptable. Obviously that does simplify down. So that would be the neatest way to give it in exact form, or we can give it to 3 significant figures. So 6.32 newtons. And let's just check that. 6.32, lovely. Let's just see how they did it in a similar way to me. They used lambda rather than m as their unknown. Oh no, they didn't actually. So they did the other way I suggested. So they basically substituted. So when they had their 4 plus p is 3 lambda, they basically said that lambda, so if minus lambda is minus 5 plus q, if you divide that through by minus 1, then lambda is 5 minus q, and they've substituted that in there. Yeah, which I won't lie, might have been I'll admit, might have been a slightly quicker way to do it. But we got the answer.